Welcome back to the Ad Blocker Developer Summit. A little bit of foreshadowing. We're going to return to the topic of browser fingerprinting in just a little bit. But before that, we have Abdul Haddi Amjad, who is a PhD student at Virginia Tech University. Haddi is researching how to leverage software engineering techniques to solve network security problems, and his presentation today discusses a new solution by his team at Virginia Tech to the issue of tracker circumvention of filter lists. Haddi, welcome to the summit. We're eager to learn about TrackerSift.
Thank you so much for the introduction first. And hi, everyone. Thank you so much for attending my talk. So today I'll be talking about one of our research approach, that is a TrackerSift. So it's basically a novel approach to untangle mixed tracking and a functional web resources. This approach is also accepted at IMC 2021 this year. So before that, I'm going to just spend like a couple of minutes establishing the problem first, and then I'll just discuss our approach. So in a bigger picture, basically, there are two main key players. One advertisers and trackers, and the other one is content blocking tools. So these advertisers and trackers are basically engaged in an escalating arm race with these privacy enhancing content blocking tools. These publishers always come up with, ad block circumvention techniques or take help from like third-party service providers to publish their ads for monetization. Whereas on the other side, we have these, the content blocking tools, who are trying their level best to block these privacy invasive ads and trackers by using different kind of filter lists that we have in a current status quo. So let me just give you some normal scenario. For example, you have a web page without any, you have a browser without any ad blockers. So you visit a web page and it loads an advertisements from an external server. But with ad blocker, obviously it cannot load those advertisements from an external server. So the obvious question that comes in how this ad block circumvention works. So these advertisers and trackers use, different kind of approaches to circumvent these content blocking tools. There are many popular approaches out there. One of them is, frequently change the network location of ad or a tracking resources. For example, doubleclick.net is one of the very popular advertising domains, and it's blocked by most of the content blockers these days. So to overcome this, these publishers might try to serve ads from a different or maybe an obscure domain, say unblockads.net, to circumvent these content blockers. Currently, content blockers have to manually update these filter lists and just make sure that these obscure domains are blocked. Similarly, another very popular approach is to bundle or mix the tracking and a functional resources. For example, for publishers, it's very easy to use CDN or a first-party domain to serve both tracking and a functional resources. When this happens, content blockers are in a kind of no-win situation. Obviously, because if they block these domains, then they might break the legitimate functionality. And if they don't, then user privacy is obviously compromised. So to address this issue, content blockers have to implement like more fine-grained approach where they have to come up and analyze some resource URLs. For example, canyoublockit.com initiated by ads.js can still be blocked, but whereas canyoublockit.com initiated by content.js can still allow. Another very common issue with the content blockers, especially using the filter list, is the granularity. So one of the conducted studies proved that ad blockers using generic filters with a broader scope, it might cause like 65% of the errors. So these filters with the broader scope, we mean the set of rules that cannot be blocked just to avoid the site breakage. So the example on slides is from the easy list that have this small allow list just to fix the site breakage. So again, to untangle these mixed resources, content blockers have to come up with like more fine-grained approach. However, for trackers, it's very easy to mix the URL information of tracking and a functional resources. For example, they can simply inline the tracking script that makes it a first-party script along with the other functional first-party scripts. We have seen like Facebook pixel tracking script, which is inlined on many web pages. And obviously, content blockers cannot block such inline tracking script based on URL information. Moreover, publishers also sometimes use different web bundling tools, such as Webpack, to mix tracking and a functional scripts. For example, we have also seen Facebook pixel tracking code bundled with functional code that's responsible for navigation and images on the page. Again, content blockers are in a very no-win situation here because they cannot block these such bundle scripts. And when they try to block such bundle scripts, this result in a significant breakage of legitimate site functionality, as you can see on here as a site. For example, when we try to block one of the bundle scripts on Prezel.co, it renders the entire web page useless with square functionality breakage. Now, I think we have established the problem. We have to come up with like more fine-grained approach, and here comes the TrackerSift into play. So it's basically an approach to untangle mixed resources at multiple levels of granularity in an hierarchical fashion. It starts from the coarse granularity of domains, which is used in tools like in current status quo like disconnect. For mixed domains, it analyzes the hostname information in a fully qualified domain names like Pi-hole. For mixed scripts, it further analyzes for mixed host names, it analyzes the initiator script URLs like NoScript. And for mixed scripts, it further analyzes the script methods to classify tracking and functional resources. To the best of our knowledge, TrackerSift is the first approach that is able to analyze and detect the tracking resources beyond the script level granularity. Let me just walk through an example to illustrate how basically TrackerSift works. It would be helpful for everyone sitting over here. Say you visit a web page and it initiates a request from 3 different domains: ads.com, google.com, and news.com. Ads.com is only serving the tracking request, so we block it. News.com is only serving functional stuff, so we allow it. But google.com is the problematic one. It's serving both tracking and a functional request. So we cannot decide at this level. So we have to go one level deeper. That's the hostname level. Say we have 3 different host names for google.com: ad.google.com, cdn.google.com, and maps.google.com. Ad.google.com is only serving the tracking request, so we block it. Maps.google.com is only serving functional requests, so we allow it. But again, cdn.google.com is the problematic one because it's serving both tracking and a functional request. So we cannot even decide at hostname level, and we have to go one level deeper. That is the script method level. Now we see, let's say just see all the requests for cdn.google.com is being initiated by 3 different scripts: sdk.js, clone.js, and stack.js. So sdk.js is initiating tracking requests for cdn.google.com, so we block it. Script stack.js is initiating functional requests for cdn.google.com, so we allow it. But again, script clone.js is the problematic and the mixed script. So we have to go and analyze things at the method level granularity. So here comes the TrackerSift novelty, and we see like 3 different methods from clone.js, say method M1, method M2, and method M3. Method M1 from clone.js only initiates tracking requests, so we block it. Method M3 from clone.js is clearly initiating functional requests, so we allow it. And in the end, we are just left with the mixed methods M2, and we have some exclusive ideas in our future work to even extend the TrackerSift to address this issue. We'll be discussing in a couple of next slides as well. But before that, let's just talk about the high-level implementation of TrackerSift. So TrackerSift uses an instrumented browser to crawl websites and track the provenance of network requests at the granularities of domain, hostname, script, and method level. For this, we have created a Chrome extension that used DevTools API to collect the relevant information. So for instance, you visit a web page, it initiates multiple HTTP requests to fetch resources. And in the middle, we have our Chrome extension to capture these HTTP requests during the page load and saves them in a database. For the labeling part, after crawling the website, each request is labeled as tracking or functional using crowdsourced filter list as a ground truth. TrackerSift then simply counts the number of tracking and a functional requests initiated by resources at various granularities. So let's see our metric. So if a resource is responsible for 2 orders of magnitude more tracking requests than functional, then it's classified as tracking. If a resource is responsible for 2 orders of magnitude more functional requests than tracking, then it's classified as functional. And obviously, the resources without this clear separation are classified as mixed. Let's look at a result summary, and then we'll go in detail afterwards. We deployed TrackerSift on 100K randomly sampled websites from Tranco top million list. Our results show that 54% of the requests are classified as either tracking or functional. And a very big number, 46%, cannot be separated even using tools like disconnect. As we move down to hostname level, 65% of the requests are classified as either tracking or functional. And we still have like 35% of the requests that cannot be separated even using tools like Pi-hole. As we slide down to script level, 94% of the requests are separated, and still there is 6% that cannot be separated using tools like NoScript. Finally, TrackerSift is able to classify 98% of the requests as either tracking or functional at the method level granularity. And again, for the remaining 2%, we have a solution in our future work. Before that, let's jump in and just have some detailed view of our results. So at domain level, it detects 51K functional domains, 7K tracking domains, and 12K mixed domains. For these 12K mixed domains, we have to go one level deeper, that is the hostname level. At the hostname level, it detects 9K functional host names, 4K tracking host names, and 12K mixed host names. And again, for these 12K mixed host names, we have to go one level deeper, that is the script level. So at the script level analysis, it detects 135K functional scripts, 194K tracking scripts, and 21K mixed scripts. And again, for the 21K mixed scripts, we slide down to the method level analysis. At method level granularity, it detects 40K functional methods, 18K tracking methods, and 6K mixed methods. And once again, TrackerSift is the first tool to analyze the methods of the script and classify 98% of the requests. Now let's talk about for the 2% of the requests that cannot be even separated after this whole sifting process. We believe that just by removing the point of divergence, in this regard, the point of divergence is basically the method that only participates in the stack traces of the tracking request. If we just block this point of divergence, then we'll break the chain of events that invoke this tracking behavior. Let me just explain this whole stuff with an example. So for example, we have this functional request and its call stack graph. Similarly, we have another tracking request and its call stack graph. Now, by looking at these two call graphs, it's very clear that method M2 from clone.js is the mixed initiator method, and it is among 2% of the requests because it cannot be separated at even method level granularity. So now we have to identify the first point of divergence in this call graph. So which is very clear that method T from track.js is this only one that is solely participating in the call stack of the tracking request. So we believe that just by blocking this, we can break the chain of events that is invoking the tracking behavior, and eventually we will be able to untangle the 2% of these mixed resources as well. So this concludes our work. TrackerSift is basically an hierarchical approach to progressively untangle mixed resources, and it can be used to build like more fine-grained content blocking tools. You can reach out to us if you have any questions. But before that, I really want to thank all the authors and advisors on this paper, starting from Danial from FAST, Zaffar from LUMS, Mohammed Ali Gulzar from Virginia Tech, and Zubair Shafiq from UC Davis. Thank you so much. If you guys have any questions, you can reach out.
Yeah, well, thanks so much, Haddi. I certainly learned a lot. It looks like our questions are going to be asked in the Slack channel, and we will take a quick break, and we'll be right back.
Sure. Thank you so much. Bye-bye.
Thanks so much. Well, Haddi, if you're still there, we actually did have a quick question that it is quite important. We wanted to bring you back. Thanks for being flexible about that. Vikas has asked, how does TrackerSift attribute calls to specific methods in a script?
Okay, so that's a very interesting question. So basically, the methods are for the initiator scripts first, and second, how we attribute those methods, right? So for each method, we just have group by the method with the number of requests it's actually initiating. So if initiating like more tracking requests than the functional requests, then it's classified as a tracking method. And if it's if it's initiating more functional requests than the tracking one, so it's classified as a functional one. And for that exact numbers, we just shared the slide where I just established the metric for ourselves that if it's greater than like 2 orders of magnitude tracking request, then the functional, so it's tracking, and otherwise it's functional.
Yeah, that's brilliant. I think that TrackerSift really has the potential to address a lot of issues that we're facing right now. So Haddi, thanks again for presenting, for coming back. We really appreciate you being flexible, and we're really eager to see where TrackerSift goes in the future. Thanks so much.
Yeah. Thank you so much.